according to the National Electrical Code, Section 250.29. D. The main bonding jumper or jumpers shall not be smaller than the largest service entrance conductor or equivalent area for parallel conductors. This means that if you have multiple conductors in parallel serving as your service entrance conductors, you need to determine the equivalent circular mill area of all those conductors combined to determine the minimum size of your main bonding jumper. In your scenario, you have 10 sets of 600 kc mill conductors serving a 4000 amp service. The code requires a minimum 750 kc mill main bonding jumper based on the size of your service entrance conductors. The code does not permit the use of parallel jumpers when the code mandates a specific minimum size based on the size of the service entrance conductor. You must use a single conductor that is at least 750 kc mill for the main bonding jumper. Using two 400 kc mill conductors in parallel does not meet the requirement of 250.29. D, which stipulates that the main bonding jumper or jumpers must not be smaller than the largest service entrance conductor. The key here is understanding that 250.29. D establishes a minimum size requirement. When a minimum size is specified, you cannot achieve that requirement by using multiple smaller conductors in parallel. The intention of the code is to ensure that the main bonding jumper has sufficient ampacity and mechanical strength to safely carry fault current back to the source. Using a single conductor of the appropriate size provides a more reliable and robust connection than using multiple smaller conductors. It's crucial to consult the latest edition of the National Electrical Code and any applicable local amendments to ensure compliance with all relevant regulations. Incorrectly sized or installed main bonding jumpers can create dangerous conditions and increase the risk of electrical shock or fire. Firstly, consider the purpose of the main bonding jumper. It's designed to provide a low impedance path for fault current to return to the source, which facilitates the operation of overcurrent protective devices like circuit breakers or fuses. Secondly, understand the specific wording of 250.29. B. The phrase "not smaller than the largest service entrance conductor" clearly indicates a minimum size requirement. Thirdly, remember that the code is designed to ensure safety. The minimum size requirement for the main bonding jumper is based on calculations and engineering principles that are intended to prevent overheating, arcing, and other potential hazards. The reason why you can't use parallel jumpers in this situation is because the code mandates a specific minimum size for the main bonding jumper based on the size of the service entrance conductors. This requirement is in place to ensure that the main bonding jumper can safely carry fault current back to the source. When the code specifies a minimum size, you must use a single conductor that meets or exceeds that size. Using multiple smaller conductors in parallel does not meet the intent of the code and is not permitted. The function of the main bonding jumper is to connect the grounded conductor, typically the neutral, to the equipment grounding system at the service entrance. This connection provides a path for fault current to flow back to the source, allowing overcurrent protective devices to trip and clear the fault. A properly sized main bonding jumper is essential for ensuring the effectiveness of the grounding system. In addition to 250.29. D. There may be other sections of the National Electrical Code that are relevant to the installation of the main bonding jumper. These sections may address issues such as the material of the conductor, the method of termination, and the protection of the conductor from physical damage. It's important to review all applicable code sections to ensure that the installation is compliant. The size of the service entrance conductors is directly related to the size of the service. A larger service will require larger service entrance conductors, which in turn will require a larger main bonding jumper. The code provides tables and guidelines for determining the appropriate size of service entrance conductors and main bonding jumpers based on the load requirements of the building or facility. When determining the size of the main bonding jumper, it's important to consider the entire service entrance. This includes all of the conductors that are used to supply power to the building or facility. If there are multiple sets of conductors in parallel, the equivalent circular mill area of all of the conductors must be considered. In your case, you have 10 sets of 600 kc mill conductors. To determine the equivalent circular mill area, you would multiply the circular mil area of a single 600 kc mil conductor by 10. This will give you the total circular mil area of all of the conductors in parallel. The main bonding jumper must be sized based on this total circular mil area. The material of the main bonding jumper is also important. The code typically requires that the main bonding jumper be made of copper or aluminum. The specific type of material that is used will depend on the application and the requirements of the local code. Copper is generally preferred for its high conductivity and corrosion resistance, but aluminum may be used in some cases, particularly for larger conductors. The method of termination of the main bonding jumper is also critical. The code requires that the main bonding jumper be securely connected to both the grounded conductor and the equipment grounding system. The connections must be made in a way that ensures good electrical contact and prevents loosening or corrosion. Approved connectors and methods should be used to make these connections. The main bonding jumper must also be protected from physical damage. The code requires that the main bonding jumper be installed in a location where it is not likely to be damaged by impact, abrasion, or other physical hazards. If the main bonding jumper is exposed to physical damage, it should be protected by conduit or other suitable means. The main bonding jumper is a critical component of the electrical system. It is essential for ensuring the safety and reliability of the system. A properly sized and installed main bonding jumper will provide a low impedance path for fault current, which will allow our current protective devices to trip and clear the fault. In summary, the National Electrical Code requires that the main bonding jumper be sized based on the size of the service entrance conductors. The code does not permit the use of parallel jumpers when the code mandates a specific minimum size. The main bonding jumper must be made of an approved material and must be securely connected to both the grounded conductor and the equipment grounding system. The main bonding jumper must also be protected from physical damage. Always consult the latest edition of the National Electrical Code and any applicable local amendments to ensure compliance with all relevant regulations. The requirements for main bonding jumpers are essential for safety and proper electrical system function. Understanding these requirements and adhering to them is crucial for qualified electrical professionals. It's not about finding loopholes, but about ensuring a safe and reliable installation. Remember, the purpose of the electrical code is to protect people and property from electrical hazards. Compliance with the code is not optional, it is a legal and ethical obligation. When in doubt, always consult with a qualified electrical engineer or inspector to ensure that your installation is compliant with all applicable codes and regulations. The interpretation of the National Electrical Code can be complex and may vary depending on a specific application and the local jurisdiction. It is important to stay up to date on the latest code changes and interpretations to ensure that your installations are compliant and safe. There are many resources available to help you stay informed about the National Electrical Code, including training courses, seminars, and online forums. Take advantage of these resources to improve your knowledge and skills. The correct installation of the main bonding jumper is not just a matter of following the code, it is a matter of protecting lives and property. Take the time to understand the requirements and ensure that your installations are compliant. If you encounter any challenges or have any questions, don't hesitate to seek guidance from qualified professionals. Their expertise can help you navigate complex situations and ensure a safe and compliant installation. Electrical safety is everyone's responsibility. By following the code and taking the necessary precautions, we can all help to prevent electrical accidents and injuries.